Part 2 of section 5.9 is writing polynomial functions using finite differences. I actually want to do this problem second. I'll do this problem first. Here's a set of points. I have no idea what this graph looks like. Is it a quadratic? Is it a cubic? Is it a quartic? Is it x to the fifth? Well, here's how we can figure that out. If we subtract, if we find the differences, this will be the first order difference. 0 minus 8 is negative 8. 8 minus 12 is negative 4. 12 minus 12 is 0. 12 minus 8 is 4. 8 minus 0 is 8. We keep going until we get a constant. So negative 8 minus a negative 4 is negative 8 plus 4. That's negative 4. Negative 4 minus 0 is negative 4. 0 minus 4 is negative 4, and 4 minus 8 is negative 4. So this is the second order difference. And by my second order difference, I get a constant. This tells me that my function must be to the second degree. Second order difference, second degree. So it must look like this, ax squared plus bx plus c. So I have three unknowns. I don't know what a, b, and c are. If I have three unknowns, I need three relationships. Well, I can choose any of these points up here. I'll choose some of the easiest ones. I know that, and I'm going to write it this way, I know that when x is 1, I know that y is 0. And I know when x is 2, I know that y is 8. And I know that when x is 3, y is 12. So there's my three relationships. Three unknowns. Do you guys remember how you want to solve that? We want to use matrices. So this gives me 1a plus 1b plus 1c equals 0. 4a plus 2b plus 1c equals 8. 9a plus 3b plus 1c equals 12. So I set up my matrix situation. 1, 1, 1, 4, 2, 1, 9, 3, 1, and then this is times A times B times C, and I get 0, 8, 12. And if I call this my matrix A, this is my unknown matrix. I'm looking for these coefficients, A, B, and C. And so I can't divide, so how do I get x? X is going to be the inverse of A times B. And I probably should have done this ahead of time. But remember, second matrix, I'm going to edit matrix A. It's a 3 by 3. And I have 1, 1, 1. And 4, 2, 1. And 9, 3, 1. And then I have to go back to matrix, go to B, then edit. And that's going to be a 3 by 1. And that's 0, 8, 12. I'm going to take the inverse of A and multiply by matrix B. And so I call up matrix A, I raise it to the negative 1, and then I multiply by matrix B, and A is negative 2, B is 14, and C is negative 12. So if I come back up here to my function, f of x is negative 2x squared plus 14x minus 12. And again, if I plot that function, these points should be on it. So a more complicated one, I already started because the video would take a long time. But here's my set of points. I did my first order difference. 39 minus 15 is 24. 15 minus 5 is 10. 5 minus 3 is 2. You see you don't get a constant. 24 minus 10 is 14. 10 minus 2 is 8. 2 minus 0. Again, you don't get a constant. By the third order, you get a constant 6. So that means I have a cubic, ax cubed plus bx squared plus cx plus d. So now I have 4 unknowns. So I need 4 relationships. So again, I can say a times 1 cubed plus b times 1 squared plus c times 1 plus d was -1. And then if you want to, I'll wait actually. And then a times 2 cubed plus b times 2 squared plus c times 2 plus d was 3. When 2 went in, 3 came out. When 3 goes in, three came out. And remember, we have, even though it's a cubic, we have 4 unknowns, a, b, c, d, so I need a 4th one. When 4 went in, 5 came out. So these are going to be my coefficients. This is 1a plus 1b plus 1c plus 1d. And 8a plus 4b plus 2c plus 1d. 27a plus 9a plus 9b plus 3c plus 1d. So here are my coefficients. 1, 1, 1, 1, 8, 4, 2, 1, 27, 9, 3, 1, and 64. Oops. 4 squared is 16. 4, 1. And then again, my unknown matrix are those coefficients I'm looking for. And when I multiply this by this, I get these. -1, 3, 3, 5. And if I call this matrix A, and that matrix X, and that matrix B, if I can find the unknown values, if I take the inverse of A and multiply by B. And I won't take the time to do that, but you can figure that out based on what I just did. End of the chapter on polynomials. Time to get ready for the test.